The ICTR-PHE 2012 conference was held at the end of February 2012. The conference was attended by over 600 participants from both the medical and physics communities. Among the contributions that physicists are bringing to the table is the development of new detector techniques for medical imaging.
Currently, many developments ongoing in detectors that may be possible for high-resolution multimodal imaging in the clinic. These are developments that originally have been done for high-energy physics, and they are now becoming available for nuclear medical imaging. In addition to the detector developments, electronics, fast analysis of signals is of utmost importance to really bring those fascinating new possibilities into the clinic.
Radiotherapy is the natural field where physicists and medical doctors are collaborating.
La radiothérapie a trois mérites. Elle est curative, elle guérit 50% des malades. Elle est conservatrice, c'est grâce à la radiothérapie qu'on garde l'œil, qu'on garde le larynx, qu'on garde un sein, qu'on garde son intestin. Et la troisième qualité, c'est qu'elle est coût-efficient. Ça veut dire que la radiothérapie en France, tout compris, c'est 1 milliard d'euros, alors que le cancer, tout compris, c'est 15 milliards d'euros.
Today, radiotherapy uses mainly photons, but other particles, such as protons and carbon ions, are increasingly being exploited as projectiles against malignant cells.
So proton therapy and carbon ion therapy are both therapies that use ions, charged particles that stop in the tumor. Both types of particles have their own best sites to treat and best tumor types to treat.
When powerful beams are delivered to tumours, it becomes crucial to have very effective control of the beam itself. For that reason, physicists bring technologies learned in high-energy physics experiments to the medical accelerators.
The control of the beam is very important in therapy, in proton therapy in particular, because the target is basically the patient, so you have to be precise. And what we tried to do is to develop an innovative method which has to be very simple for hospitals.
CERN was indeed strongly represented at the ICTR-PHE 2012 conference, thanks to its widespread participation in medical physics-related projects and to its involvement in a number of projects relating to the development of detectors, readout techniques, and particle acceleration solutions.
Following the previous conference here in 2010, the CERN Directorate, CERN Management, set up 3 initiatives. The first one was to design a new cost-effective accelerator for cancer therapy. The second one was to set up a user facility for radiobiological tests, and for this we want to use the beams at CERN, in the accelerators at CERN, when they are not being used for particle physics. And the most useful one there is the low-energy ion ring, which is only used for about 2 months a year for LHC ion runs. The third thing is to set up a user facility for radioactive isotopes. And for this, the first part in the radioactive isotopes is first of all to set up a database of what would be useful and where you could find it.
One example that involves CERN accelerator infrastructure is the MEDICIS project. It aims to produce a wide variety of isotopes for medical use.
Nous allons positionner l'installation MEDICIS comme étant donc intégrant un réseau européen d'installations qui fournissent des isotopes pour des applications médicales, avec une spécificité, ça sera de pouvoir produire une grande variété d'isotopes de très grande pureté, mais en quantité relativement limitée, qui seront probablement suffisantes pour des essais, jusqu'à des essais précliniques. Mais le CERN ne va pas positionner l'installation MEDICIS pour faire de la production commerciale d'isotopes. On garde notre mission de recherche fondamentale et de service pour la communauté scientifique européenne.
What does space science have in common with better healthcare on Earth? The ICTR-PHE 2012 conference also showed how information coming from tests and experiments in space can contribute to fighting cancer.
Space radiation protection has a lot in common with therapy, and in particular with particle therapy. And the reason is that the same particles that we use on Earth to treat patients are a risk in space for the astronauts. So we have a lot of topics in common. In particular, for example, the risk of secondary cancer in therapy is the same kind of problem that we have in space radiation protection. So there is a big role of biologists, of course, because we need to understand the risk, and there is also a big role of physicists in designing especially shielding and countermeasure for space travel. I think these two communities, the particle therapy community and the space radiation protection community, should really interact much more and work together toward both the dream of a mission to Mars and a better therapy on Earth.
The ICTR-PHE 2012 Joint Conference closed its doors on the 2nd of March after sealing the alliance between the physics and medical communities. The message that physicists need to play an even greater role in the fight for better healthcare came across very strongly at the public talk given by Søren M. Benson, Professor of Human Oncology at the University of Wisconsin. He said that a brand new science is being created by the collaboration between physics, biology, chemistry and computer science. We can expect to see several powerful and innovative solutions for better healthcare in the not too distant future.